here. It is a happy day indeed because you have the ability to watch me on video even though I am not there. This presentation pretty much is what you guys need to know for today's notes to fill in. I want to make sure that we are connecting some ideas of where we've already been with functions. I also want to make sure that you guys are clear as to what you need to do to complete the work for today. So sit back, relax, make sure you're taking notes as you do this, and hopefully you will pick up what I'm putting down here. So let's take a look at what you need to know for today. All right, so here is a warm-up that I want you guys to give a shot. This is stuff that you've already covered before, and it's definitely something that you've done in the past, but you gotta be good at these particular types of problems in order to be successful today. So take a second here, write these 4 problems down in your notes where it says warm-up, and give them a shot. Try and simplify each of these expressions. What you need to remember is order of operations here, so recall those order of operations and give these ones a try. So pause the video here so that you can give these guys a shot before I show you the answers. So pause it. Pause the video. Pause it. Is it paused? Good. All right, so hopefully you tried these bad boys out and you were not pausing like a pretender here. But remember that order of operations here stands for the way in which we simplify expressions here. So for this first one, I see that I have 2 times 3, and that is the first thing that I need to do. So that 2 times 3 gives me 6, minus 1, which gives me 5 as my total answer. For number 2, I see I have parentheses, so something that I need to take care of first is that 2 minus 1, which gives me 1, plus 4, which gives me 5. Cool. The third problem here, I see I've got those exponents, so be very careful. One of the biggest mistakes that you can make when you see an exponent is think that 2 to the 3rd power gives you 6, but that is wrong. Remember that 2 to the 3rd power actually means 2 times 2 times 2, plus 1 here. So 2 times 2 times 2 gives you 8 plus 1, which is 9. This last problem here for number 4 requires you to remember just one simple fact, and that is CLT, aka collect like terms from our Unit 1 test. So if I see a 2x and a 4x, I know that I can combine those bad boys because they are like terms. That gives me a 6x, and that negative 2 plus 3 gives me a plus 1 in total, and my final answer here in my expression is 6x plus 1. So these types of problems will definitely help you on your way to understanding the material for today. So make sure you follow along and understand these order of operations. So far in this unit, we've done pretty much 4 things to functions. We've graphed them, we've used tables to graph them, we've discovered what the input and output means in the graph, and we've also described them in terms of their movement in general. What we need to make sure that we understand for today is how we actually represent functions. So that's going to help us understand them more deeply and really dive deep into the things that you need to understand for this unit test. So let's take a look at how we represent functions. So today's topic comes in 3 different ways. So we're going to have function notation, which is something that is brand new to us, evaluating those functions, and then adding those functions together. So 3 things you're going to get good at today are all listed here. So here is what we need to make sure that we understand by the end of the day. So let's take a look at the first skill. All right, so here we've got some blanks for you to fill in your notes. And the brand new piece of information is how we represent functions. So what you can see is that we have this brand new notation. It's called function notation. And it looks like multiplication, but it's not multiplication. How we actually say this in math speak is that this is f of x. Now what this represents is an actual function now. So if you remember when I introduced functions, I gave you this picture of this machine. And this machine had an input and an output. Now this function machine is now called f of x, and what we put into it is x, and what we get out is our output y. So this is sort of a new picture for you to make sure that you understand in terms of function notation. So we still have the same input and output. The only thing that we are now discovering is that this function now has an actual notation attached to it. So let's take a look at our first example here and see if we can manage to get these function machines to work. All right, so here is our first example of a brand new function notation. And what you can see is that I've got my f of x here. Now what that means is that my machine is now described by this particular algebraic expression, which is 2x plus 1. Now what this means is that this machine is going to change everything that I put into it by this type of expression. So if I'm looking at my first question here, finding f of 1, that means that what I'm inputting into my machine is the number 1 here. So that is going to get replaced in my function machine everywhere that I see an x. So if I see an x here, I'm going to replace it with my input, which is 1 now. Now all I have to do to figure out what my output is here is simplify the expression. So 2 times 1 gives me 2, plus 1 gives me 3 as my output. So now I have my answer for f of 1, which is 3. F of negative 1 I can find in a much similar way, so the machine stays the same. It's still 2x plus 1 in the machine. The only difference here is that my input is going to be negative 1 instead of 1. When I input negative 1, the machine takes that into the x, and now all I have to do is make sure that I simplify. 2 times negative 1 gives me negative 2 plus 1, which gives me negative 1 as my output. So f of negative 1 is now equal to negative 1. So what this is really a game of substitution and making sure that you're able to simplify these things once you replace the input for the number that we're replacing it with. So let's take a look at example number 2 and let's get good at this. All right, so example number 2, almost identical. The only thing that I'm changing here is the numbers. So I still have f of x, which means that my function machine is going to be described by this 3x minus 2. So what this means is whatever I input into this machine, I'm going to change that x to make sure that it goes through the machine and gives me an output here. So the first function that I'm looking at, the first input that I'm looking at here, is I'm looking at an input of this positive 1. So f of 1 means that I'm plugging 1 into my machine here. So now I'm going to replace every x that I see with a 1. And now all I have to do is simplify. So 3 times 1 gives me 3. 3 minus 2 gives me my output, which is 1. So my input here is 1. I started with a 1. And what the machine did is it turned that 1 and maintained it as a 1 after I plugged it in. So my answer here is 1. The next thing that we have to do here is find another input to our function. So the function that we're looking at is the same 1, but we're inputting negative 1 instead of 1. So how this changes my machine is wherever I see an x, instead of replacing it with the positive 1 from the first example here, I'm going to replace it with a negative 1. So this x over here gets replaced with a negative 1, and that minus 2 comes down. 3 times negative 1 gives me negative 3 minus 2, which gives me a negative 5 as the output. So this is where we need to make sure we understand the relationship between an input and an output. So the input is what we're replacing x with, and the output is what we get after we simplify. So this is how we use these specific functions to figure out what we get as an input and an output. All right, next one here. Again, it's the same idea, but all I have to do here is make sure that I'm careful with the exponent that's in my machine now. So my machine is going to have this expression inside of it, which is x squared minus 2. What I need to figure out are two different inputs here. My first input here is if I input a 2 into my machine, what do I get out of it? So if I input 2 here, I'm replacing every x in my machine with a 2. So that x changes to a 2, that exponent stays there, minus 2. 2 squared is just 2 times 2, which is 4, and 4 minus 2 gives me my output, which is 2. So when I input 2, my output is 2. So that's just coincidence here. Don't think that that's always the case. Make sure you're plugging in your value here into your function machine. The next function that I'm looking at, or next input that I'm looking to put in here, is a 0. So I'm going to replace that input with a 0 and see what happens when I plug this into my machine. So I still have x squared minus 2, but everywhere I see an x, I'm going to replace it with a 0 this time. So now I have 0 squared minus 2. 0 squared is just 0. 0 times 0 is 0. So I get 0 minus 2, which is just negative 2. So in this case, my input of 0 gives me an answer of negative 2. And bada bing, bada boom, there is another function done and done. So let's take a look at our last example and make sure you take some good notes here. Right, so this one's going to be the most challenging one of the bunch because it throws a lot of order of operations at you. But let's just pretend we're doing the exact same thing as before. The function machine here has changed just a bit because the function inside is now 2x squared plus 1. So my first input that I'm looking at is plugging in 1 here. So now my input is 1. So if I plug in 1 to this function machine, everywhere that I see an x, I'm going to replace with a 1. Now this is where order of operations comes in handy. So I don't see any parentheses except for the one that's attached to the exponent. And I know for a fact that exponents come first in this thing before multiplication. So I get 1 squared, which is 1. It's not 2, it's just 1. And I bring everything down here that I haven't yet simplified. So now I have 2 times 1, which is 2, plus 1, which gives me 3. So my output here for this particular input is 3 here. So f of 1 gives me 3. Let's see what happens if we start with a brand new input. So same function, the only thing that I'm changing here is what I'm plugging into my function machine. So I'm going to plug in -2 here, and wherever I see an x, I'm going to change it with a -2. So again, what comes first here is the exponents according to my order of operations. So that's -2 squared. So be careful here. If I have -2 squared, that gives me -2 times -2, which gives me a +4. Make sure you don't fall into a silly trap here where you think that that negative is still there. So -2 squared gives you a +4. Whoops. So make sure that does not do any weird math there. Make sure you're still going true according to what squares mean. So now let's finish up this problem. So I've got 2 times 4, multiplication comes first here. I get 8 plus 1 comes down, and that gives me a 9 as my total answer here. So at the end, my output is 9 when I input -2 into my function. So we can boil this down to pretty much one necessary skill, and that's just substitution. And you guys know how to substitute, you guys know how to simplify. The only difference here is that we're talking about functions. So this is the major skill for today. Let's take a look at a secondary skill for you guys to get good at here. All right, so the secondary skill for today is adding these functions together. And realistically, we've already done this before because we know how to combine like terms. Combining like terms here is the exact same as in Unit 1 when we're adding x's together and regular numbers together. So it's the exact same skill. The only difference here is that we're dealing with functions. So let's take a look at how we can make a connection here between something that we've done to something that's brand new to us. So let's take a look at example number 1. So example number 1 is pretty straightforward. Here I've got 2 functions. One of them is called f of x, the other one's called h of x. And what I need to do is I'm looking to add them together. So here's all I need to do to add these 2 functions together to get one end function. So if I take f of x, which is just 2x plus 1, and I add it to my second function, which is h of x, which is x minus 2, all I need to do now is just combine some like terms. So what I can see is I have a 2x and an x. 2x plus x gives me 3x. Cool. The next thing I combine is a 1 and a -2. 1 and a -2 gives me a -1. And my super function here after adding them both together is just 3x minus 1. So this is nothing more, nothing less than just combining like terms. So let's take a look at example number 2. All right, so here's example number 2. Again, all we're doing here is we're combining 2 functions together by collecting like terms. So I've got f of x here and I've got my h of x here. So all I'm going to do is combine them by adding them together. So my first function here, f of x, is -x minus 2. And I'm going to add to it that second function, which is 3x plus 4. Now that I've put these together using some addition, all I'm going to do is combine some like terms. So I see the -x and the 3x combine to a positive 2x. -2 and a positive 4 also combine here to a positive 2. So that means my super function here, after I've added them together, is 2x plus 2. So again, nothing more, nothing less than just combining like terms here. Let's keep going. Right, so here's our next example here. The only thing that you got to be careful about is making sure that you're adding the right functions together. So notice I've got an f of x, an h of x, and a third player here, which is g of x. So the first problem here says find f of x plus g of x. That means that I'm only worried about two specific functions here, so make sure that you're using the right functions. So in order to add these two functions together, f of x is 2x plus 1, and I'm going to add to it negative 3x plus 1. So now all I got to do is the same thing that we were doing before in the previous two examples, which is collecting like terms. I see I have 2x and a negative 3x. That gives me a negative 1x, or a negative x here. Whoop. And last but not least, I've got a 1 and a 1, which gives me a positive 2. So my super function here, after I add it all together, is negative x plus 2. Next one, I see I have the h of x and the g of x being added together. So again, make sure you're using the right functions here. So my h and my g are the following. So I've got x minus 2 plus that negative 3x plus 1. So again, combine some like terms here. I've got x and a negative 3x, so that gives me a negative 2x. And last but not least, I've got a negative 2 and a 1, which gives me a minus 1. So there is my super function there. Only lesson here is to make sure that you're using the right functions if you have more than one. So this right here is how you add these functions. So last example, let's make sure you guys are pros at this by now. All right, so last example here, I'm going to do this vlog style because I think that's a little bit more fun. But this last example here is interesting because it has an interesting function attached to it. So I see, again, I'm adding these two functions, f of x and h of x. Let's see what happens when we combine these bad boys. So if I do this, I get x squared plus 2x plus 1. And what I'm going to add to it is h of x, which is x minus 2. So here is your first taste of a brand new type of term, and that is this x squared term. Realize that no other term in this particular expression has an exponent attached to it. That means that that is a lone wolf. It can't be combined with anything, and you've got to make sure that you leave it alone. So that x squared is left alone as a term that can't be combined with anything. But we do see that we can combine these two x's and this 1x here. When I combine that 2x and 1x, I know for sure it gives me a 3x, so that comes next in my expression. Last but not least, I've got these regular numbers, 1 and a negative 2, which gives me a negative 1. And this right here, ladies and gentlemen, is my final statement when I add those functions together. So one of the biggest things for adding functions is you got to remember that the terms that you're combining need to be like terms, meaning that they should definitely look the same, and they should not only have the same expression or exponent attached to them, but make sure that you are combining the ones that can only be combined together. So this is the last and most difficult example. You might or might not see this on the extra credit assignment for today, but I'll explain more with regards to what you're responsible for now after you've watched this video and you've taken some notes here. So let's take a look at the conclusion slide here so that you know what to do after this, and so that you can get some work done and make sure you get your full points for the week. So let's take a look. Done with the notes here. Hopefully what you do now is pretty simple. So just make sure that your notes are all filled in. Even the reflection questions at the end, make sure you do like a little blurb about what you learned today. And then pick up the practice worksheet from the sub and the extra credit worksheet if you want it from the sub as well. So there's a little offer of extra credit there. If you want to take it, it's completely up to you. I got to be honest with you, you probably have enough time to finish it in class anyway, so you might as well give it a shot. The mandatory practice worksheet, however, is something that you need to make sure that you get done and include it into your packet that you're turning in on Friday. So make sure that you're working through that. Once you finish that, I'm going to post a brand new part to the digital study guide, and has everything to do with functions, the unit that we're in right now, so you can keep on adding to that particular digital study guide. So in the next slide, I'm going to go over a couple of the example problems from the practice worksheet. So pause the video here, grab the worksheet from the sub, and come back. I'll still be here, and I'll do 2 problems for you that are on that worksheet, just so that you're off to the good start here. So pause the video and go ahead and pick up the worksheet from the sub. So pause the video. I'll be right here. Did you pause it? Okay. Awesome. Make sure you get that. Cool. All right, let's move on to the example problems. Examples numbers 1 and 2, so these are actually on the practice worksheet. This one's mandatory, so you got to make sure you know how to work your way through this. What you see here in numbers 1 and 2 is you see two different functions and the inputs that you should replace the x's with. So for number 1, I see that the first input that I'm looking to do is this -2. Now what I do with that -2 is in that function, I'm going to replace every single x with that -2. So I have -3, parentheses, -2. Why? Because I made sure to replace that x with my brand new input. Now from here, all I need to do is follow the order of operations and simplify. So parentheses, I see there's some around the -2, but the next thing that I'm looking at is exponents. So for the exponents, I have -2 squared. -2 times -2 gives me a +4. So remember that. That -3 is still out there, but that -2 squared gives me a +4. Cool. There's my next step. My next step here requires me to multiply because I know that's what comes next in my order of operations. -3 times 4 gives me -12. And that -3 still comes down because I haven't done anything with it yet. -12 minus 3 here, plain and simple, is -15. And bada bing, bada boom, -15 is my answer. Now what you'll find on this worksheet is that some of them are pretty easy. So if you look at number 2, I have g of x is equal to x minus 2, and my input here is -3. So that means that I'm just going to replace that x again with a -3, and that -2 comes down because I haven't touched it yet. So that -3 minus 2 gives me one simple step here, which is -5, and bada bing, bada boom, I'm actually done with that problem. So all you have to make sure that you do is when you're substituting here, you simplify to the best of your abilities using the order of operations. So hopefully this gives you a good head start on that mandatory practice worksheet. Keep on working through it and make sure you get that done before Friday. So at this point, it is all on you. Make sure you get some stuff done today. Be respectful to the sub, and I will see you tomorrow. Peace.